Yeah, so this recording, I'm going to show a benchmarking code that I wrote to benchmark the reasoning agent in AG2 with the different search strategies. I'll show the MCTS benchmarking first. So let me go to the code. So, okay, so this is the code. This is where the data that we'll use to benchmark it. So the data has 10 questions with the ground truth answer, and this is the prompt, right? And then I created a benchmark folder. In that, I created a base class, base benchmark, which is an abstract method, run benchmark and write benchmark output. The idea is for each of the search strategies, we'll have a separate benchmarking module like this, which will inherit base benchmark, then implement the run benchmark logic in that particular search strategy, and write it in the benchmark output file using the write benchmark output, right? So this is the base class. Then the MCTS search strategy uh, uh, is the benchmarking for the MCTS search strategy is in MCTS reasoner benchmark program, where I have this class inheriting the base benchmark. I instantiated the MCTS agent class, MCTS reasoner agent. This one I have written under the reasoner algos, right? The reasoner algorithm also has a base class with the base reasoner agent. It has an abstract method where it will return the agent, and it has a implemented function which will return the user proxy. In the benchmark, when I use MCTS search strategy, this MCTS reasoner agent is coded in the MCTS reasoner agent .py under reasoner algos. It's very simple. It's MCTS reasoner agent is a class name. Instantiate from the base reasoner agent. This is the config list that I gave it, and I just returned the agent, right? MCTS agent. So this class I instantiated here. Then this is okay. I'll come to this later. First, let me go to the run benchmark. Run benchmark is what now I instantiated here, right? So if you remember, benchmark had this run benchmark, right? So the run benchmark, I take the eval list, which will be the the content of this data set, instructions, right? So right now the sample bench public.json has this as the prompt. But if I want to add additional instructions to the prompt, that's what this instructions does. And out file by default, it will write to the output of the benchmark in the benchmark result.jsonl, right? Then for in the eval list, if you see in the eval list, I have the eval data, I have a list of this question answer. There are total in 10. There are 10 in total. So now the reasoner benchmark for each eval in eval list, I am extracting the question ID, prompt, and the answer, right? Extracting the question ID, prompt, and the answer, right? Then if instruction is not none, if I give some instruction, I take the prompt and add the instructions to it. Then I create the MCTS agent, right? From the class, right? From this class that I just showed, right? I return the MCTS agent. I return the user proxy. Then I gave the summary arguments as question ID, prompt, ground truth, and out file, right? This is my summary arguments. When I initiate the chat now with user proxy.initiate chat, I gave the message, which is the prompt, right? I created here. Summary method, I want, like while it is running, I want this summary method to run to extract the benchmarking result. And this method will take the summary arguments, right? So now we'll go to the last meaningful message function. So this is where now I have the summary args. For each of the questions in the data set, I can extract the question ID, prompt, ground truth, out file, right? And then I will capture the chat message from the recipient. And this chat message is a list of messages which are the interactions between the user proxy and the MCTS agent. The last one will have the terminate one. So that's why I'm reversing it. Right? So this will be reverse chat message. And this is where capturing the summary, right? The basically the final answer is captured here, right? That's what I take here. Then I create a benchmarking result, right? In the benchmarking result, since in the summary, so if you look at the instance, when I run it, right? I run it using run MCTS benchmark.py. Here, I gave the instruction as give the final answer in the below format, right? I tell it to give the answer in this below format. So when it runs here, sorry, here, right? Um, right, in the summary, I have the answer like this. Let me see. Um, it will be like this, right? It will have answer as the key and the actual answer, right? And this is what I'm doing, right? So I am taking the summary, right, and converting it to a valid JSON, and then the predicted truth, which is a predicted answer, is the value of the answer key, right? This is what I'm taking the predicted truth. Rest of the information I already have in the summary args, right, with which I'm creating the benchmarking result now, where I'm taking the question ID, prompt, the ground truth, and this is what I got as the predicted truth. And as I mentioned, the predicted truth, when I prompt the language model, I ask it to give it in a specific format with answer as the key. I take this as a predicted truth, and then this benchmarking result is what I write in the benchmarking output, which is there in the benchmark.py, right? I write it into a file, and the default file name is benchmarking result.json, right? This thing, this logic that I just mentioned, I run it using the run MCTS benchmark.py, right? So here, as I mentioned, this is the data file. This is this data file, here, right? I load it here. Then this is all my data from this file. This is the instruction, additional instruction for each prompt I want to add. Give the final answer in the below mentioned JSON format, right? And remember to share only the output in JSON format. Do not add anything else, right? This is what I pass to the run benchmark. This is the logic that we just went through, right? Where I give the eval list and the instruction, right? This is the one that we went through, right? Eval list, instruction, right? And finally, when the initiate chat runs, it executes last meaningful message, captures the summary, and writes it into my out file, right? So after running this, the out file will be like this, right? Question ID, prompt for each of them, right? Prompt, then the ground truth, which will directly take it from here, and the predicted truth, right? This is the file that I'll get, right? The benchmark summary.py, I wrote this to read this file, right? Read this benchmark result file and give me a summary of the percentage of correct predicted truth, right? So if I run this, actually it is reading this file and saying that out of 10 questions, 2 were correct. So there are 20% correct. Right? So this is how I wrote this one. I'll probably make some more changes to it to make it more user friendly. Right now, to run this, right? So you can go to the terminal and say Python um, run. First, you run this, right? MCTS benchmark. So this will run this program. Create your benchmark result.jsonl. If you want to change this file name, the run benchmark, you can give the out file, right? Right now it is defaulted to benchmark result.jsonl. I'll make it like an argument later on, but right now you can run it. Once you run it, you will see the benchmark result.jsnl file created. You need to have the .env file for sure. The .env file, you need to give the OpenAI underscore API underscore key, right? Um, OpenAI underscore API underscore key equal to, you need to give the your OpenAI key, so that when the prisoner runs, right? So this is the key you need to define in the .env, right? OpenAI API key equal to your API key, so that it can get this and then run this, right? Um, yeah. So after you run this, you will get this file and then run the benchmark. Uh, then you do a Python benchmark summary, which will give you the summary of the benchmark. My idea is also to actually push it to, let's say, Blanksmith or any other like weights and biases weave, right? So that it is more user friendly. For now, this is the first version of the benchmarking code. Thank you.